Hello, class. All right, so in this video, we are going to look at uh, the graph of sine and cosine functions. Okay, so take notes. Trigonometric functions, but we're not going to look at all of them. Okay, so hopefully you notice that here, when you were doing your sine and cosine and tangent of your reference angles, if you noticed, like let's say here, this is 0, over here it's pi over 2, halfway around is pi, 3 pi over 2, and then when we go full circle, we end up here at 2 pi. And if we keep going around and around and around, it doesn't really matter if I'm at 2 pi and then I go a little bit beyond 2 pi, right? If I go, like, let's say 1/4. Okay, so if I go 1/4 pi, okay, beyond 2 pi. So 2 pi and 1/4. Okay, so 9/4 pi, right? It doesn't really matter how many times I go around, right? So whether I go all the way around and then land here, right? I can go even another 2 pi, right? 17 pi over 4, okay? Or no, 13 pi over 4. Okay, so 17 pi over 4. Okay, so if I keep going full circles, but I keep landing over here where the reference angle is pi over 4, we keep getting the same value, right? Sine of whatever that reference angle is still going to be square root 2 over 2. Okay, so hopefully you notice that no matter what happens after you do one full circle, all of the values start to repeat again. Okay, it doesn't matter where you land, you'll still get the same answer as you did in that first round, in that first circle. Okay, all right, because of that, when we look at the graphs of sine and cosine, what happens is it does one full cycle and then it just sort of repeats itself. Okay, so let's take a look here. Okay, so a function f is periodic if there is a positive number p such that if you do f of t, right, and you add, say, full circle to that t value, you're still going to get the same result. So, okay, for every t. And this p-value is known as the period of f. Okay, so in the case of the sine and cosine functions, that period would be 2 pi, because after you go one full circle, it doesn't really matter. You're still going to keep getting the same results. Okay. All right. So let's take a look at the basic graph. Okay. Of sine. So we'll start off with the sine function, and we'll do the cosine function. Okay. So first of all, I have this. Okay, f of x equals sine x. Okay. All right, so we know that it has one full cycle, one period at 2 pi. It's from 0 to 2 pi. Okay, so let's get some key points. Let's suppose we make a table of values, and I'm just going to go ahead and take the quadrantal angles. Okay, so when x is 0, when x is 90 degrees, or pi over 2, okay, pi, these are the ones that were on your chart that you had to memorize. 3 pi over 2, and then back full circle at 2 pi. Okay, so here, I'm just going to draw this off to the side here. All I did was take this one, this one, this one, the quadrantal angles, okay, and this one, okay. And let's see if you remember what the sine values are for all of these. Sine of 0, 0. Sine of pi over 2, 1. Sine of pi, 0. Sine of 3 pi over 2, -1. And sine of 2 pi back to 0. And then we repeat these again, even if I keep going around and around and around. Okay, so based on that, let's take a look at the graph. Okay, so I'm going to go ahead and pretend that this is 2 pi. So halfway between is pi. Okay. I don't want it to get too crowded, so I won't put in the pi over 2 and the 3 pi over 2. Okay. But they are here and here. Halfway between and halfway between. I'm just going to put this here to show you in a minute what this is going to look like if we do more than one cycle. Okay. All right, so, but we're only going to graph it from 0 to 2 pi, one full cycle of the sine function. All right, so right here at 0, sine of 0 is 0. So we have a point right here. And if sine of pi over 2, which is halfway between 0 and pi, we get 1. So right there. And sine of pi is 0. Sine of 3 pi over 2. 3 pi over 2 is halfway between pi and 2 pi. Okay, so we get -1. And 2 pi, we get 0. Okay, so this graph ends up looking like this. Okay, so that's for one period. Okay, so we can go on and on and on. And what happens is, again, these values that you see here that are plotted happen again and again and again. So if I went all the way to 4 pi, okay, I would see that exact same graph again. Okay, so if I continue to make this graph, then I would, again, 0 there, 1 up here, 0 here, -1 here, and back to 0 again. Okay, so I would end up getting another sine wave. Okay, and I can go to 8 pi. If I go to 8 pi, then, 6 pi, then I would get also another wave, even in the other direction. Okay, so if I go the other direction, then we know that here Okay, so if you can try to imagine if you go in this direction or this way, right? Negative angles. Okay, so here I get 0. Okay, and then at 3 pi over 2, I get -1. And then for negative pi, I get 0. And then -3 pi over 2, I get 1. And then I get back to 0 again. So again, I get the same sort of sine wave. Okay, and it goes on forever and ever and ever in both directions, left, right. Okay, this is what happens. Okay, but what we become concerned with is just one cycle. One cycle is good enough, one period. Okay, so do I need all of this? Nope. When if I asked you to graph, then doing that piece right there, this graph is good enough. Okay, just having the one period. Okay, so let me put my axis back. Okay, so having just the one cycle is good enough. Okay, so and that these points you can derive just from doing this basic chart that I did here. But like I said, you should have had that chart memorized so you can just plot them. You don't need to have this table of values. Okay. All right. So let's take a look at transformations. Okay. So this is the parent function that we are working with here. And you're used to doing shifting, and we will be doing a shifting of up and down and a stretching or shrinking or uh, flipping it over the x-axis. Okay, so the one, however, that gets a little tricky is the sideways shifting because they do a little bit extra stuff here. So I'm going to show you how to deal with the shifting, the left-right shifting. Okay. All right, so transformations. So one thing you want to just keep in mind is that when you're graphing the sine function, okay, we know that on the left end point, it's always at 0, okay? And then we go up 1, and then we're at 0 again, and then -1, and then 0. Okay, that's the basic shape of one cycle of the sine graph, right? Okay, and that's pretty much all you need to know. And then everything else is like you calculate what the new endpoints are, and then you do your shift. Take all the points and then shift them up or down. Or if you have a stretch, then you multiply your y values and you stretch it. Okay. All right. So let's take a look. So let's go ahead and graph y equals let's use f of x. F of x equals sine x plus pi minus 2. Okay, so so over here, and remember, we get this one, we get this graph, one full cycle between 0 and 2 pi. Okay, so here, this will be like your traditional shifting. Okay, but when we do the horizontal shift, it's more of like a change of endpoints. So here, this basic graph, the endpoints are at 0 and 2 pi. And here they will not be. Okay, so So what happens is when you have something inside here, okay, all of this, okay, when you have something inside here, inside the sine function, that's going to change your endpoints. Your endpoints will no longer be 0 and 2 pi, okay? So what happens is you are going to take this, your endpoints change. And yes, this is just a shift to the left pi units. But when they start throwing a multiplier in there, then it gets a little trickier. Okay, so I want you to, even though yes, that's clearly a shift left, I want you to kind of get used to doing this calculation here. So it changes the endpoints. Okay, so instead of 0 and 2 pi, okay, what's going to happen is you're going to take that, whatever's inside there, inside here is x plus pi, okay, and you're going to solve for x. Okay, so we're going to subtract pi here, all three sections. Okay, so what happens is now this is going to tell me that I'm going to get one full cycle between negative pi and pi. Okay, so whereas before it was like, okay, I was going to get this, these 5 points between 0 and 2 pi. Now you're going to get those same 5 points, but they're going to be between negative pi and pi. Okay, and this is your traditional shift, vertical shift down too. Okay, all right, so let's take a look. So when you graph this, okay, so I'm going to need negative pi and pi. Okay, and now I get those 5 points. Okay, so those 5 points, we said, are here, and then halfway between it's 1. Okay, 1, 2, 3, 4, and 5. Okay, so I'm going to just do a dash graph. Okay, because we're not quite done. This isn't the final graph because now we have to shift it down too. Okay, so now I'm going to take all 5 of these points and shift them down too. So 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So now that takes care of all of the transformations. It takes care of my horizontal transformation and my vertical. Okay, so my final graph will be like that. Okay, so again, this part right here might be the part that you're not familiar with. Okay, so but you'll see this method right here of finding your new endpoints for these 5 points. These 5 points right here. Okay, so finding the new endpoints, it's, to me, I think it's a little bit easier than trying to figure out the shifts and factoring out a 2 and this, that, whatever. This is much easier. Okay, so just find out what your new endpoints are, and then you can plot your 5 points and then do your shifts. Okay, so let's take a look at another one. Okay, so let's go ahead and graph. Negative 2 times sine x plus 3. Okay, so here, the only thing inside of sine is x. So here, your endpoints are not going to change. They're still going to be 0 to 2 pi. They only change if you have anything added, subtracted, or multiplied, or divided with x, okay? So the endpoints remain. You are still 0 and 2 pi, okay? This one here, you're going to shift your points up 3, okay? And then this one here tells me that I am going to multiply my 5 points, multiply the original y values. Original y values. Okay. Okay, so once you put your 5 starting points down, whenever there's this multiplier out here, you definitely want to do this first, okay? And then you can shift up, down, because if you shift up or down first, well, then you lose track of your original y values, right? Because now your points have moved. Okay, so let's go ahead and graph this. And again, my 5 points are going to be placed between 0 and 2 pi. 0, 2 pi. All right, so there's pi. Okay, so you know it starts off 1 here, 2, 3, 4, and 5. Okay, so, and it's between 0 and 2 pi, okay, in this case. All right, so we need to do these two things, multiply the original y values by -2 and shift up 3. So let's do the multiplier first. Multiply the y values by -2. Here I'm going to use a different color. Let's use red. 0 is the y value here for this first point. So 0 times -2 is still 0. Okay. The second point up on top. Okay, so the y value is 1. So 1 times -2 is -2. Okay, so I need to plot it down here. Okay. Okay, so -2 way down here. Okay. This third point at pi, the y value is 0, so 0 times -2 is still 0. Okay. The next point down below, okay, so it's -1. -1 times -2 is +2. So I need to get that up here. And this last point, y value is 0, so 0 times -2 is 0. Okay, so here I have this graph, right? Okay, this is not going to be my final graph. This is just the what it looks like when you multiply it by -2. Okay, so it flips and it gets stretched. We still need to shift this 3 units up. So I'll do that one, the final graph in, let's do green. Okay. All right, so shifting these all up 3. I'm going to need some more. 1, 2, 3. Okay. So let's get the green back. All right, so final graph shifts it up 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3, and 1, 2, 3, and 1, 2, 3. So my final graph looks like this. Okay, so that's what it looks like multiplied by -2, which makes it get stretched. Okay, and shifted up 3. Okay. All right, let's try another one. Let's try another one where the endpoints change. Okay, so let's take a look at this one. So let's go ahead and graph f of x equals, let's do 1/2 sine. Let's put everything in here. Sine, so we have that multiplier there. And now I have 2x minus pi over 2. So this is why I say it's a little more complicated to figure out the shifting once you start doing this 2x. Okay, if it just said x minus pi over 2, then yeah, that's an easy shift. That's a shift to the right pi over 2 units. Okay, but here it says 2x minus pi over 2. Okay, which changes things. Which is why I don't want you to just do your normal horizontal shift. Oh, 2 units to the right or 2 units to the left or whatever like that. Just to find out, solve for your new endpoints. Okay. All right. So this in here, let's do that first. Tells us that we are going to have new endpoints. So it's not going to be between 0 and 2 pi anymore. Let's find out what it's going to be between. Okay, so we take whatever's inside there, 2x minus pi over 2, and we solve it between 0 and 2 pi, the original endpoints. Okay, because 0 and 2 pi are the original endpoints, we're trying to figure out what the new endpoints are. Okay, so let's go ahead and solve this. So I'm going to add pi over 2 to all 3 parts. Okay, so that gives me pi over 2, 2x, and this is going to give me 5 pi over 2. Okay. All right, so we need to still divide by 2 or multiply everything by 1/2. And so that will give me, so multiply everything by 1/2 to cancel that. Okay, which is the same thing as saying divide by 2. Okay, so that's pi over 4 and 5 pi over 4. Okay, so what this means is you're going to have those 5 points, not between 0 and 2 pi, but from pi over 4 to 5 pi over 4. Okay, so let's take a look. Pi over 4 is positive. Okay, so it's still over here. So here's pi over 4. And here's 5 pi over 4. Okay, so let me do a 1 here. All right, so we're going to have those 5 starting points of the sine graph between pi over 4 and 5 pi over 4. Okay, so we're going to have a point right here. That's 1. Then here, that's 2. Here's 3. Here's 4. And here's 5. Okay, so that alone already takes care of our horizontal shifting. Okay, so now what we need to do is take care of this right here. We have to multiply our original y values by 1/2. Those three that are on the axes, those are all 0. So their y values right now are 0. So when you multiply by 1/2, they're all going to stay there. Okay, so hopefully you notice that. So these multiply by 1/2, you're still going to be at 0. Okay. This top one, well, right now the y value is 1. So when you multiply by 1/2, it's going to come down here to 1/2. And same thing with this one on the bottom. When you multiply that by 1/2, it's going to go over here to negative 1/2. Okay. You can do the graph if you want in a different color. If you have different colors, great. If you don't, then just do the dash, or don't graph it at all. Okay, just keep track of your points. Okay, so now we need to do this part, which is shift up 1. Okay, so let me get that green back. All right, so this first point, this first red point on the left here, is going to go up 1. This one here, that's at half, so it's going to go up 1 to 1.5. This third point goes to 1. This one way down here goes up to 1/2. And then this one here goes up to 1. Okay, so here is my final graph. Okay, so again, this here takes care of your horizontal shifting. Okay, so just do that, figure out where your 5 points are going to go between, and plot them. Then all you have to do is deal with this and this as far as your transformations go. Okay. All right, let's go ahead and take a look at the cosine graph. And it basically works the same way. So what we need to do is take a look and see what the basic cosine graph looks like. Okay, so similar to sine, cosine has one full cycle from 0 to 2 pi, and then the values start to repeat. Okay, so it's also periodic, just like sine. Okay, so let's take a look at just this cosine, cosine x. Okay, and let's pull up our chart and let's do it in table form. Okay, so we'll look at, again, just the quadrantal ones: 0, pi over 2, pi, 3 pi over 2, and back to full circle 2 pi. Okay, so again, that's like at 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360. Okay, all right, so cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. 3 pi over 2 is 0. And 2 pi brings us back to 1. Okay, and if we go another full circle, we get these same values again. Okay, so let's go ahead and graph what this looks like. from 0 to 2 pi. Okay, so from 0 to 2 pi, halfway between is pi. Here's 1 and -1. Okay, so we have 0, 1. So we have a point there. Pi over 2, 0. So there's our second point. Pi, -1. It's going to be right on the pi. Okay. 3 pi over 2, 0. And then 2 pi, 1. Okay, so you might be looking at these 5 points and thinking it's a V or a U, but it's not. So what happens is it's like this is also a wave. Okay, so this is so it's going to look the graph, if we do this for several cycles, it'll look like the sine graph. It's just it's shifted. So so here, let me just kind of show you. So if this is what you think of for the sine graph, and then we have many parts of it. Okay, so what happens is the cosine graph has the same shape. Okay, it's just that we're looking from 0 to 2 pi. We know sine has this part from 0 to 2 pi. So what happens is with cosine, we're not looking at that part of this wave. What we're looking at is that V thing that you think you see is not a V. It's actually this part of the wave. So this top part from here to this top part over here. Okay, so that's the part of the wave that we're doing here from 0 to 2 pi for cosine. Okay, so let me go ahead and graph that. So if we were to continue with another, so make sure you kind of curve that. Oops, my hand jerked. So make sure you're kind of curving that because you're trying to get that part of the wave. You should be imagining a bunch of waves, and you're only drawing that part of it. Okay, so that if I were to graph this for another period, right, that would be 4 pi. Right? So it would be 1 point here, and then 0, and then -1, and then 0, and then 1. Right? And so you would see that you would have that. Okay? So you see the wave happening. Okay? Even if you were to go this direction in the negative direction, if you go to -2 pi, right? Okay, so if you go to -2 pi, you would see the same thing. You would have a point here, 1, 0, -1, 0, and then, oops, not there. And then back to 1. Okay, so not that one. So here again, so you would see this wave. Okay, but again, we're concerned about graphing one cycle. So let's just focus on one cycle. If it says to graph, two periods or 2 cycles, then then do 2 periods. Okay, so but hopefully you see the similarity, but that we are just going to focus on one part of the wave Let me erase that. We're only going to focus on that part, okay? All right. So again, it starts at 1, and then 0, and then -1, and then 0, and then 1, okay? All right, so let's take a look at one that has some transformations. And again, so here it has one full cycle from 0 to 2 pi. If there are any sort of horizontal transformations, then you will have new endpoints, just like with the sine graph, okay? But you'll have that exact graph. All right, so let's take a look. So let's graph f of x equals negative cosine of 2x minus pi plus 1. Okay. So again, if that said x minus pi, easy horizontal shift, but it says 2x minus pi, so now it gets a little blurred. Okay, so instead of trying to figure out, oh, well, I have to shift it, but how much do I have to shift it? Let's not worry about that. Let's just get the new endpoints. Okay, so right here, we're going to get new endpoints. So we're going to have those 5 points, not between 0 and 2 pi anymore. But let's find out where. Okay. All right. So we take that's inside 2x minus pi, and just like sine, I'm going to set this between the original endpoints, which are 0 and 2 pi. And then I solve for x to figure out where my new endpoints are. Okay. So I'm going to add pi to all 3 parts. Okay. So I get pi is less than or equal to 2x, less than or equal to 3 pi. Divide everything by 2. Okay. And so we get that our new endpoints are going to be 3 pi over 2 on the right and pi over 2 on the left. So you're going to have those 5 points, right? Not between 0 and 2 pi now. You're going to have those same 5 points between pi over 2 and 3 pi over 2. Okay, so let's go ahead and plot those 5 points. And here's pi over 2 and 3 pi over 2. Okay. All right, and we know that it is, let me bring down the equation. Okay, so 1 and -1. Okay, all right, so we have those 5 points. Let's go look back at them again. We have these 5 points right here. Okay, exactly the same, 5 points, except over here between pi over 2 and 3 pi over 2. So we have the first point over here, okay, and then 1 here at 0, halfway in between, and then over here hits its lowest point in the middle, and then back to 0, and then back up to 1. Okay, and again, it's sort of that that wave. Okay, it's not a V. All right, and then everything else is pretty straightforward. Once you have your 5 points set between your new endpoints, then you can go ahead and multiply the y values by -1. And then once you do that, then you can take those points and shift them all up 1. Okay. multiply the y values. All right, so let me get a new color for the y values. All right, so this first point, the y value is 1. Multiply it by -1, and it ends up down here. The ones on the axes are going to stay on the axes, okay? So that's going to stay there because the y value is 0. 0 times anything will be 0. Okay, so this third point down below is -1, and you multiply it by -1, and you get +1. Okay, and again, this one stays on the axis. Okay, and that last point multiplied by -1, and you end up down below. Okay, so it's reflected over the x-axis. All right, so we have this here cosine graph. Okay, I'm going to do kind of a dashed graph so you can kind of see it. All right, we still need to shift this up 1. Okay, so we're going to take these red dots and shift them all up 1. Okay, let me do it in green again, if I can get it. There we go. All right, so take the red dots and red points and shift them all up 1. So there's 1. This goes up 1. Where are you? There you are. This goes up 1. And this one goes up 1. And this last one goes up 1 to the axis. Okay, and so here, again, try to curve it. You should be curving it right away. Okay, so that's what you would have for your cosine graph. Okay. If you have any questions, just you can always take a picture, send me your work via the Remind app, or you can email me. Again, if you want a quicker response from me, then doing it through the Remind app is much easier. Oh, there is one more thing. I don't normally ask this on the test, but this is good to know because I think your homework might be asking for it. Okay, so it asks for amplitude. So amplitude, that's like how high your waves go. So maybe like sound waves or okay, so that has high amplitude compared to this one. Okay, so and the period, which is like your frequency. Okay, so like you might have this. Okay, so this period has a longer period, whereas this one might have the same amplitude. Okay, but it has a shorter period. Okay, so it's going to ask you questions like, oh, what's the amplitude? What's the period? What's the phase shift? Okay, so let's kind of talk about that, and then we'll wrap it up. Okay, so amplitude and amplitude, period, and phase shift. Okay, so if you have, so let me just give you the equation for the sine and the cosine. So if you have a sine function, y equals a times sine, k times x minus b. Okay, or if you have the cosine, y equals a cosine k x minus b. Okay. And of course, in both of these cases, k is greater than 0. Then these three things, amplitude, period, phase shift, can be determined by some of these variables here. Amplitude will be the absolute value of A, because whether or not you reflect this over the x-axis, the amplitude is still the greatest value. Okay. The period, so how long it takes for it to reach one full cycle, is going to be 2 pi over k. All right, and your phase shift. Okay, so your phase shift would equal that b value. Okay, and so just make sure that you pay attention to the structure of the equation when they ask you for that phase shift. Very important that you definitely make sure that